So this was your homework question. So you have to calculate the forces in the members AB, BC, and AC. So how to solve this? So if you assume the nature of forces in this direction, suppose force in AB member is this to prevent this force. This is F of AB. For this, F of BC, right? Now, if you see this point B, you can pick it out and draw the forces system like this. Suppose 20 kilonewton here on the point B or joint B. From this side, force in AB member, that is 20 kilonewton given in the question, and this force in BC member, right? So three forces meeting at a single point. This is nothing but the concurrent force system. So for the concurrent force system, we can apply a Lami's theorem. So if 60, this is 30, this must be 90, right? This is the 90 degree. If this is 60, this must be 60, and this is 90. So this becomes 150 degree. Now 360 minus 150, 90, it becomes 120 degree. Okay. Now you can easily apply the Lami's theorem to find the forces AB and BC. So using Lami's theorem, we will get 20 by opposite sine angle sine 90, that is nothing but 1, will be equal to force in AB member by sine 120. From here, f of AB will be equal to 20 by sine 90 into sine 120 is equal to, so 20 sine 120 is equal to 17.32 kilonewton. That's all. Similarly, 20 also 20 by sine 90, sine 90 is 1, is equal to f of BC, opposite angle is 150, f of BC, force in BC member, opposite angle 150, sine 150. From here, f of BC is equal to 20 sine 150 is equal to 20 sine 150 must be 10 kilonewton, right? So we have calculated this force in this member, but left force in the AC member. How to calculate it? Now see, if the component, if this is force in AB member, its horizontal component must be f of B, then cos 60, right? So for AC member, the horizontal component summation of all the forces in horizontal direction would be 0. Now suppose to prevent this, the force is something like this, right? So f of AB cos 60 plus force in AC member will be 0, right? Both are acting on the right hand side. So f of AC is equal to negative of f of AB cos 60 is equal to, why f of AB cos 60? Right. The nature was compressive. Wait. One mistake. The force is compressive in nature, right? So iska horizontal component, I am taking a point A. So the horizontal component of this force must be like this, and in the opposite direction it is F. So this is FAC, this is F of AB cos 60, F of AB cos 60, right? So directly we can write F of AB cos 60 will be equal to F of AC, which is equal to, just multiply it. F of AB, force in AB member was 17.32 cos 60. Solve it. 17.32 cos 60. That is 8.66. Right? So we have considered this FAC as tensile force. So it's the value is positive. That means it is the tensile force. Similarly, I have considered force in AB member as compressive. AB is compressive in nature. Similarly, the direction at joint B is considered as compressive. So force in BC member is also compressive. Right. So this is the shortcut method solved by the Lami's theorem. When you do practice, it will take less time. Okay. Now let's start the next question. Another question we have to solve. This is a lengthy question for the mains. Suppose the truss right. Now let us connect. Here is supports provided. One is hinged, other is roller. And let us provide two forces, one here and one. Say, suppose this is 40 kilonewton, this is 50 kilonewton. Mark as A, B, name them G, E. Let the distance between them is 2 meter. This is the question. Now you have to calculate this question. You have to calculate the forces in each member. Calculate forces in member. Right. So first of all, let us calculate the reactions. Why? Because choose any point as per method of joint. क्या सीखा था हमने? Method of joints में we have to choose that point where there is only two unknown force system, because equation of equilibrium available is only two. So only two force can be resolved. So if you talk about this point A, there is three unknown forces. This force in AB member, force in AE member, and reaction. Three unknown forces you cannot solve. E has more members. D has the same situation. B has another, again three members. So first you have to eliminate the number of unknown forces. How you will eliminate? You can eliminate at point A if you find the reaction at A. Similar the case at D, right? So first of all, let us calculate the support reaction. Now, calculation of support reaction. Summation of all the forces y direction must be 0. So let the upward reaction at A this is the reaction at A, say RA, and this is the upward vertical reaction at D, RD. So the force equilibrium, upward forces should be equal to the downward forces. Upward forces कितना है? Upward forces are RA plus RD is equal to downward forces 40 plus 50 is equal to 90 kilonewton. Question number 1. Now, two forces, two unknown forces and only one equation, we cannot solve it. We require one more additional equation. Additional equation will be summation of all the moments at point C must be 0, right? So I am not saying that truss is subjected to the bending moment. I am not saying that. I am just calculating the moment of forces. As the truss is in an equilibrium condition, the summation of all the force moment shall also be 0. So I am taking the advantage of this moment equilibrium equation. So now taking the moment at point T, how many forces are there? RA, support reaction. How much distance is away? So RA into 4. RA into 4 minus, for the loads, 40 into 3. 40 into 3 minus 50 into 2 must be 0. Solve this. RA will be equal to 120 plus 100 by 4 is equal to 40 into 3, 50 into, oh sorry, 50 into 1. 50 into 1 is equal to 0. RA is equal to 120 plus 50 by 4 is equal to, it's 42.5 kilonewton. But RA plus RD was 90 kilonewton, right? And you know RA, so RD will be 90 minus RA is equal to 90 minus 42.5 is equal to 47.5. Okay. So we have eliminated two unknown forces at the point A and D. RA is 42.5 and RD is 47.5 kilonewton. Okay. All right. Now, now let us calculate the forces in different members. First of all, here only two unknown forces are there, force in AB member and force in AE member, right? Consider joint A. At joint A, to draw the joint A first, this is joint A. Now, how many forces are there? This is the upward force RA. Only consider this, right? So, this is the upward force RA, that is 42.5 kilonewton. Apart from this, say this is the force F of AB, force in AB member, and another force is A. This is the situation for joint A, right? Three force system, 1, 2, 3, right? Now, one may ask, sir, how do you know that F of AB is compressive in nature? You can take any direction, right? If your answer is negative, you can change your direction. वैसे भी आप देख सकते हैं कि force is transferring here. Who will gonna support this? Obviously, AB member gonna support this 40 kilonewtons effect, right? So obviously at this joint, the member has to apply the compressive force, right? If you do not understand this, if you cannot imagine, no issue. You can choose opposite direction as if your results is negative, change the direction afterward. Now for this situation, solving horizontally, summation of all the horizontal force. First take the vertical force. Vertical force should be 0. So how many vertical force are there? Now you can see, suppose this angle is given as 60 degree, 60 degree, this is 60. Every angle is 60 degree, right? So if this angle is 60 degree, this vertical component of this acting downward, f of AB, right? F of AB of sine 60 will be equal to upward force 42.5 kilonewton, right? F of AB will be equal to 42.5 divided by sine 60. That's 49.07 kilonewton. And as the result is positive, that means the assumed direction is correct. As the result is positive, assumed direction is correct. That means f of AB, force in AB member, we have considered accurate. And what is the nature? It is towards the joint, it is compressive nature. So साथ साथ लिखते चलेंगे नेचर को भी, नेचर इज compressive, right? Now solve horizontally. Summation of all the forces in horizontal direction is also 0. So this component is in this direction is say f of AB cos 60 would be equal to f of AE. F of AE will be equal to cos 60. That's 24.54 kilonewton. What is the nature? It's going away from the joint. Tensile is the nature, right? So we have calculated two force system. Right. So AB is done, A is done. Similarly, let us move to joint D. Why not at E? E has again more than two unknown forces, right? We can proceed to this point. What's its B point, C point, right? Let us first solve D point. So consider joint D. If you consider the point or joint D, suppose this is the joint D. Upward force is RD. Yes, RD. How much it is? 47.5. It is 47.5. Right. Going upward 47.5. How many forces are there? One force like this in the DE member. So force in DE member, F of DE. I am considering it as tension, and force in CD member, it's like this. Angle is 60 degree again. Force in CD member, right? So resolve first vertically. Summation of all the forces in vertical direction should be 0. So upward force is taking positive. Upward force is taking positive. Downward force is taking negative. So 47.5 minus. So the component of this vertical component of this force CD will be f of CD sine 60 would be 0. F of CD from here will be equal to 47.5 by sine 60. This is 54.848 say round figure में 85 kilonewton. So force in CD member is find out, and this value is 54.85, but the results are positive. I assume the direction is compressive, so the nature is compressive, that's okay. Now resolve horizontally. If you resolve in the horizontal direction, this the component of FCD is away from the joint. I can write f of CD cos 60 will be equal to force in DE member, which is equal to, तो DE member के अंदर कितना आ जाएगा? FCD is already calculated as 54.84 multiply with the cos 60. It's 27.42 kilonewton. What is the nature? So DE is away from the joint, the nature is tensile. Right? Okay. So we have solved 4 members. This is done, this is done, this is done, this is done. How many members are there? 1, 2, 3, 4, 5, 6, 7. 4 has been solved. 3 members left. Which one? DE, CE, and BC. Got it? Now move forward. Now consider the joint C. Joint C. So at joint C, suppose this is the joint C. Okay. So at joint C, see how many forces are there? 1, 2, 3, and 4. 4 forces are there. Combination of 4 forces. One force is 50 acting downward. 50 kilonewton. Another force is CD acting in this direction. Another force is CE acting like this. And another force is DC acting like this. I don't know whether the directions are correct or not. I am sure for this force in CD member. Why? Because CD is compressive. I calculated here. CD is having compressive nature. इसलिए जो नेचर है कंप्रेसिव होने की वजह से इट इज टुवर्ड्स द जॉइंट, जॉइंट को कंप्रेस करेगा. ठीक है. Now 50 is known, this is known, FCD is known. How much it is? FCD was 54.85. Two forces are unknown. Force in BC member and force in CE member. Right. So we know this angle was 60 degree. This was 60 degree. Right. So this is 60. This is again 60. Right. So if the angle is 60 degree, right? This angle is 60. Now resolving the force in vertical direction first. Summation of all the forces in vertical direction 0 होना है. Take downward force is negative, upward force is positive. How many upward forces are there? The component of this FCE. So I will write FCE sin 60 plus FCD का component sin 60 will be equal to the downward force, that is 50. I know FCD already. So FCE sin 60 is equal to 3 minus FCD sin 60 is equal to 50 minus 54.85 into sin 60. Take the sin 60 from here, then sin 60. You'll get force in CE, that is equal to, that's 2.89 kilonewton. Now what is the nature? The answer is positive, it's not negative. That means the assumed direction was correct. So for CE, what I assumed, it is going upwards. नेचर क्या होगा? कंप्रेसिव. नेचर हो गया कंप्रेसिव. कंप्रेस कर रहे हैं ना जॉइंट को. Now resolving horizontally, summation of all the forces in horizontal direction is resolve horizontal in the horizontal direction. So suppose लेफ्ट हैंड साइड फोर्सेज आर पॉजिटिव, राइट हैंड साइड आर नेगेटिव, तो या इक्वेट कर सकते हैं आप दोनों तरफ के फोर्स. तो फ्रॉम लेफ्ट हैंड साइड हाउ मेनी फोर्सेज आर देयर? एफ ऑफ बी सी प्लस एफ ऑफ सी डी cos 60, right? The horizontal component opposite direction, okay. F of CE cos 60, right? Solve this. F of BC is equal to F of CE cos 60 minus F of CD cos 60. F of CE we already calculated. Force in CE member, that is 2.89. So 2.89 cos 60 minus FCD. FCD is 54.85 cos 60. Solving this, 2.89 cos 60 minus 54.85 cos 60. So the answer is, my answer is coming out negative minus 25.98. That means I assume the force BC as tensile in nature. It's going away from the joint, right? Joint से away जा रहा है ना, तो मैंने टेंशन माना है. But I found my answer negative. That means the assumed direction was incorrect. So I need to say sorry to the question and then just reverse this direction. That means I assumed it tensile, but as it is negative, I can write therefore force in BC member is of nature 25.98 kilonewton, but the nature is not tensile but compressive, right? Negative sign आने से ऐसा करता है. That means I can change the direction of this. This is the correct way. Hope you understand. ठीक है? Now, how many forces are there? Are left. BC has done this, this is also done. Only one member is there. So now we will consider the joint B. Right? Let's move to the next page. Now for joint D. Suppose this is the joint B. In this joint B, how many forces are there? So first thing first, 40 kilonewton is acting downward. The nature of BC was compressive. That means I need to apply the force like this towards the joint, compressive. Two more forces. AB member was compressive, 49.07. AB was compressive. 49.0. Right. Angle is 60 degree. One more force is there, that is BE. Now suppose this BE is in this direction. I don't know whether I am right or wrong. If I am wrong, the answer will be negative. I need to change the direction. For this BE, FOBE. This is 60, my dear. This is 60. This is also 60. This angle is also right. Now let us resolve vertical first. Summation of all the forces in vertical direction is 0. So taking upward positive, downward negative. Right. So upward forces, how many forces are there? Upwards are F of AB. The component is sine component, sine 60 minus 4. So also going down, minus F of DE sine 60 is equal to 0. Resolve this. I can say F of DE sine 60 will be equal to F of AB sine 60 minus 4. Right? ये इसको इधर लिखे गए पॉजिटिव हो गया. This is the remaining quantity. F of force in AB member sine 60. Now we know force in BE will be equal to, what is F of AB? F of AB is 49.07 sine 60 minus 40 divide by, take sine 60 here in the divide, sine 60. How much you will get? 49.07 into sine 60 minus 40 divided by sine 60. Answer is 2.89 kilonewton. Right. Nature क्या है? The assumed, because the quantity is positive. If it is positive, that means the assumed direction was correct. अगर नेगेटिव आता नो इश्यू, मुझे वापस से जाना पड़ता. ठीक है. या फिर अगर आप इस फोर्स को टूवर्ड्स द जॉइंट लगाते तो भी आपका आंसर नेगेटिव आता. अगर नेगेटिव आने से आपको फिर डायरेक्शन चेंज करना. राइट. तो नेचर कैसा है? इट्स गोइंग अवे फ्रॉम द जॉइंट, इट्स टेंसाइल. ठीक है. So all the forces in the members are calculated. Now let us write the summary for this forces system. Forces or say member and forces. Member and force. So first member AB. How much force was there in the AB? In the AB, it is 49.07. Nature was compressive. Next member is AE. So in AE, this is AE, 24.54. Nature is tensile. Force is in kilonewton. And the nature is strength. Next member is AE. Where is BE? BE is this 4.89. Nature is tensile. Another member, remember BC. Where is BC? Here is BC. BC was 25.98 in kilonewton. Nature is compressive. compressive. DC was next is DC के बाद CE EC CE member CE is 2.89. Then what left? CD and GE. For CD was 27.42. Sorry, not CD, it's DE. DE is 27.42. It's a tensile. Now CD member. There is CD. This is CD 54.85 compressive. So this is the summary. Right? So that's all. So for the method of joints, this type of question may ask in the mains actually. And prelims के लिए तो जितना short tracks हमने सीखा है, that is sufficient. This is done for today.